All right, review the test. Reflections. A reflection means to do what? It's a flip. You're flipping it over a line. Now remember, you have your cheat sheet. Now please pay attention. Make sure you pay attention to what it's telling you to flip over. I suggest you mark that line. We have colored pencils in the room. Use those. Okay? That helps. Now, when I'm going to flip it over that line, I can use the cheat sheet because it's on there, or it's very simple, I just count. So since n is above the line 1, n prime is going to be below the line 1. I is 2 above, so I'm going to go 2 below. And then m is right here. 5 above, so 5 below. So this is n prime, I prime, and m prime. So I prime, instead of being at -2, 2, is at -2, -2. N prime, instead of being at 1, 2, 3, 4, 5, -5, +1, it's going to be at -5, -1. And m, instead of being at -2, +5, is going to be at -2, -5. That's it. Now, for number 3, we're reflecting over the y-axis. That's right here. So it's going to fold over that. So n prime is just going to still be right there. That point is also n prime because it's on the axis. Now g up here is 2 away, so I'm just going to put g prime 2 away this way. Q is 1, 2, 3 from the line, so I'm going to go 1, 2, 3 the other direction. So that's going to be Q prime. And X is 2 away, so I'm going to go 2 away this way for X prime. So G prime is at 2, 1, 2, 3, 4. Q prime is at 1, 2, 3, 1, 2, 3, 1. N prime is still at 0, 1. That did not change. And X prime is at 2, -1. Remember, you can stop this anytime you need. Now, this one you have to be careful of. This is a composition. First off, let's just place the point -3, 1 on our graph. 1, 2, 3, 1. There is my point. Now, let's see what it says. It reflects over the line x equals -1. Well, we need to draw that line in. This is very important to draw that line in. Remember, x equals -1. X is always -1. -1, 0. -1, 1. -1, -5. X is always -1. Where are those points? Well, those points are right here. Whoops. Those points are right here. -1, 0. -1, 1. -9, 1. All along this line. So -1, the line x equals -1 is a vertical line. Now, it wants me to reflect across that line. So when I count, I'm not going to count 1, 2, 3 like before, because I'm not counting to the axis. I'm counting to this new green line. 1, 2. Therefore, I'm going to count 1, 2, and put my dot right here. That's my A prime. All right? Okay, I lied. Oh, no, this is a composition. Okay, so there's my first one. I have reflected over x equals -1. Now, I'm going to take that point and reflect it over that special diagonal line that goes from here to here. Y equals x. Okay? Well, this is a tricky one because of the fact that right now a prime is on that line. So to reflect over that line, it doesn't move. So actually, I am staying right there, and a double prime is the same location. Now, there's a hint. Where is A located after both reflections? At 1, 1. Now, just for example, let's say I reflected it, somewhere else. Let's say it was here. Okay? It was at 1, 2, 3, 4, 5, 1. Okay? Well, when I reflected over that line, I switch x and y. It was on your cheat sheet, and I ended up at 1, 5. Okay? These two are mirrored across that line. But since A prime was on the line, A double prime is also on the line. Kind of a sneaky trick question, but good for review discussion. Okay, reflect the following points over y equals x. So we're going to be in that special line right there, where basically x and y just switch places, no big deal. So negative 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5 is right here. And I'm just going to do the reflection right now. It's going to be 5, negative 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay? Can you see how that is reflected over that line, like so? Hopefully. All right, B, is it 2, 0? That's right here. So there's one part of my triangle. Well, where is B prime going to be? That's 0, 2. And C is going to be a negative 3, negative 4. 1, 2, 3, 1, 2, 3, 4. That's my C. And I can finish my triangle here. So there's my first triangle. A, C, B. That's horribly drawn, but worked for me. And then I switch. Negative 3, negative 4 switches to negative 4. 1, 2, 3, 4. Negative 3. 1, 2, 3. And I'm down here at C prime. And notice that makes sense. Those are kind of like right across from each other. Right? And so now I'm going to draw A prime to B prime to C prime. And there are my two triangles which fold over the line y equals x. All right. A translation means to do what? It means to slide. Given the vector negative 2, 4, what does that mean? Well, remember, this is my x-coordinate, which means left and right. This is my y-coordinate, which means up and down. So think about your x and y-axis. Plus is right, negative is left, plus is up, negative is down. So for the x-coordinate, negative 2 means left 2. And for the y-coordinate, positive 4 means up 4. All right, translate the following images along this vector. So this is x, whoops, that's x, that's y. So this is going to mean up to, my bad, this is going to mean right to the x-coordinate, right and left, and negative 1 means down 1. So I'm going to move every point right 2, down 1. So starting at y, that's not y, x, p, w, that's x up here. All right. So I'm going to move it right 2, down 1. There's my new point. Okay. W, right 2, down 1. P, right 2, down 1. And x, right 2, down 1. And here is my new shape. Here's my x prime. Here's my w prime. Here's my p prime. Oh, my bad, that wasn't x up there. That was j. Sorry. This is J. So this is J prime. And the X prime is over here. So, what's coordinates? J prime is at 2, 1, 2, 3, 4. 2, comma, 4. W is at 1, 2, 3, 4, 5, comma, 0. P is at 1, negative, oh, sorry, my bad. It's down, I was looking where the P was, not the dot. Is at 0, negative 2. It just drops straight down from the origin. And X is at negative 1, 0. And that's a simple vector slide. Now 7, 4. This is my X, this is my Y. This means right 7 and up 4. So, D, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4 is up there, D prime. Now, R is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. There's my R prime. And Q is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. There's my Q prime. And that triangle has moved right 7, up 4. Where is R prime? It's at 1, 2, 1, 2, 3, 4. D prime is at 1, 2, 3, 4, 5, comma 4. And Q prime is at 1, 2, 3, negative 1. And that's it. Now, just a remember, I can speak. If one of those numbers was 0, that means it might not move left or right, or it might not move up or down. So if X is 0, it's just going to move up or down. If Y is 0, it's just going to move left or right. Rotation. A rotation means to do what? Well, we call that a spin. So, rotate the following image counterclockwise 90 degrees. Now remember, counterclockwise, okay, think about it, is going this direction. Okay? Backwards. So 90-degree rotation is going to end up here. All right? So we're going to do our little cheat on here. And to make life easier, I'm going to write the points T, Y, J, X right here. So T is at 1, 0. Y is at 1, 2, 1, 2, 3. 2, negative 3. J is at 1, 2, 3, 0. And X is at 3, 1, 2, 3, 4. 3, negative 4. That's going to make it easier to do my cheat. Now, for a 90-degree rotation, X comma Y, what we do is the Y is going to move to the front and become opposite, and the X just moves to the back. So I'm going to come down here and just do the little magic trick on everything. So I'm going to start with the X's moving to the back. So for T, 1's going to go here. For Y, 2 is going to go here. For J, 3 is going to go here. And for X prime, 3 is going to go here. Now, when I move the 0 to the front, it becomes opposite, but there is no negative 0. Negative 3 on Y is going to become positive 3. For J prime, 0, there is no negative, and negative 4 for X prime is going to become positive 4. So when I draw those on here, 0, 1, 3, 2, 0, 3, and 4, 3. So when I draw it, there's there's my shape. And if you see, try to visualize it, it rotated 90 degrees. Okay? That makes sense. So now just label everything. So 0, 1 is t prime, 0, 3 is j prime, 3, 2 is y prime, and this is x prime up here. Don't forget to label your drawings in the test. All right, now, same shape, right? So I don't have to redraw the ty, j, x points. I'm just going to look over here to do this now. Now, remember, for a 180 rotation, x, y becomes opposite x, opposite y, no change in position. Okay? So just make everything opposite. So remember, 180 degrees, 90, it should end up here. And this point should end up somewhere, pointing towards the top after rotation. Just try to visualize that in your head. So for t, I'm just going to make it -1, 0, because there's no opposite of 0. For y, it's going to become -2, +3. For j prime, it's going to be -3, 0. Again, no opposite of 0. And for x prime, it's going to become -3 and +4. So let's put those on here. So -1, 0 is right here. That's t prime. -3, 0 is right here. That's j prime. -2, 3 is right here. And -3, 4 is right here. So that's my x prime, and this is my y prime. And then when I draw it, there you go. Rotate 180 degrees. 270. So we have the same points here, but you can go back and look at your previous page if you want. I'm just going to write them again. So t is 1, 0. J is at 3, 0. Y is at 1, 2, 1, 2, 1, 2, 3, 2, -3. And J is at 3, X is at 3, -4. Now remember, for a 270 translation, it's going to go 90, 180, 270. So think about where the point is going to be. Where is the X going? X was pointing this way, then X was pointing this way. So X is going to be pointing out this way, theoretically. Now, remember, XY changes for 270. Y moves to the front, X moves to the back, and becomes opposite. So, I'm going to start the magic right here. And I'm always going to start, my preference is to move the positive one. So I'm going to move for T, 0 comes here. For J, 0 comes here. For Y, -3 comes here. And for Z, -4 comes here. Now, X is going to move to the back and become opposite. So for T, 1 becomes -1. For J, 3 becomes -3. For Y prime, 2 becomes -2. And for Z prime, 3 becomes -3. So here we go. 0, -1 is right here. 0, -3 is right here. -3, -2 is right here. And -4, -3 is right here. And like we talked about, X prime is pointing that way, that direction. So here's my T prime. 0, -3 is my J prime. And this is my Y prime. Simple enough. Composition. Again, composition is when you do two things in a row. So, ABC has vertices at the following points. 1, 3. -2. -2, -1. Here's A, here's B, and 3, -2. 1, 2, 3, 1, 2. Nope, not C prime, just C. And connect those into a triangle. Now, it says translate it to 0. This is what I was talking about before. 2, 0 means right 2, and that's it. So, we're going to shift over 2 spots. 1, 2. 1, 2. 1, 2. And that's it. A prime, B prime, C prime. So where are those points? A prime is at 1, 2, 3, 1, 2, 3. B prime is at 0, negative 1. And C prime is at 1, 2, 3, 4, 5, negative 2. Now, my second move is going to be based on the prime, the green triangle. It says reflect over the y-axis. Well, where's the y-axis? That's right here. So I'm going to draw that in with a different color. Now, when I reflect over that axis, I'm simply going to count. Yes, you can use your cheat sheet because you have the numbers there, but it's real simple. C prime is 2 below. C double prime is going to be 2 above. A prime is 1, 2, 3 above. A double prime is going to be 1, 2, 3 below. And B prime is 1 below. B double prime is going to be 1 above. And there we go. So now when I write those out, A double prime is at 1, 2, 3, 1, 2, 3. So 3, negative 3. B double prime is at 0, 1. And C double prime is going to be at 5, positive 2. If you look at your cheat sheet, basically it says X stays the same, Y becomes opposite. All right, number 17. DE has vertices at 1, 3. And 3, negative 3. It says, translate it, negative 2, negative 1. So that's going to be left 2, down 1. So, left 2, down 1. Left 2, down 1. Here's D prime, here's E prime. Connect the dots. Where's D prime at? Negative 1, positive 2. Where's E prime at? Positive 1, 1, 2, 3, 4, 1, negative 4. I don't know what's wrong with the board. It's not. It's like a dead spot. There you go. Now, let's go back to what the second translation is. It says rotate that 270 degrees. 270 degrees. So, again, look at your cheat sheet and just look at what you do. Very simple. No big deal. For 270 degrees, Y moves to the front. So, 2, negative 4. X moves to the back and becomes opposite. So, positive 1, negative 1. That's it. So, 2, 1, that's D double prime. Negative 4, negative 1, that's E double prime. And if you think about a 270 degree rotation, let's look at that. E should have moved from this quadrant here, 90, 180, into this quadrant, 270. And that's what it did. And D should have moved 3 quadrants, and that's what it did. So it makes sense with what we've been doing. Okay. In your own words, describe symmetry. Basically, it's matching points on either side of a line. Every time we do a reflection over a line, it's symmetrical. That shape is symmetrical, can fold and match. Okay, what two types did we learn about? We learned about point and rotational. What is the order of symmetry? It's the number of rotations. Basically, how many times can you spin it around until it gets back and it's symmetrical and matches up until it gets back to the beginning. And the magnitude, you just take 360 degrees divided by the order number. I just did that at 22. So this is the same thing right there. Okay, state whether it has line symmetry. Yes or no, and draw all lines of symmetry. Okay? So, with this shape, if I rotated it, let's see, just see if I can show you how this would work. See how that rotates? It's a little bit off. But you see how that rotates there? It matches up. It's not perfect because this board's a little bit off. But see how it rotates? Now, how many times did it rotate? One. Well, I'm talking about rotational symmetry. We're talking about line symmetry. But basically, I can draw a line right here and fold it over on itself. Well, if you can kind of imagine, if you tilt your head, that point to that middle of that line is the same as that point to the middle of that line, and that point to the middle of that line, and that point to the middle of that line, and that point to the middle of that line. Okay? So if you imagine rotating it, so how many lines did I draw? 1, 2, 3, 4, 5. I do 5 lines. Whoopsie. Okay, this shape is a no. Okay, the only way this shape rotates and ends up on itself is a full 360 degrees. I'm sorry, again, I did rotational, but line symmetry, there's nowhere I can draw a line and fold it and have it match up. It just doesn't work. Okay, this one, number 25, if I fold it across the middle or this way, top to bottom, think about the grade school hamburger or hot dog bun, I can fold it 2 different places. All right, now since my brain is stuck on rotational symmetry, let's talk about this. So I'm going to draw this shape as carefully as possible. Oh, that was horrible. All right, but let's see what happens. I can rotate this shape 1 time, 2 times, 3 times, till it gets back to start. So does it have rotational symmetry? Yes. 3 times, and 360 divided by 3 is 120 degrees. Okay, this is going to be a treat. All right, so let's see. Can I rotate this? Does that match up? If it was drawn better, yes, it does. So it does 1 time and then back to start 2 times. So the answer is yes to 180 degrees. This one should be really great. This is getting worse and worse along the way. Okay, but watch what happens. I want you to look at the flat edges. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So yes, 8 times, and then 360, okay? You don't know off the top of your heads, okay. 360 divided by 8 is 45. degrees. Okay, which of these have a horizontal line of symmetry? Well, let's draw a horizontal line straight through this bad boy. There we go. Which one of them folds top to bottom? Well, this one does. This one does not. This one does not. This one does. This one does. This one. S always confuses people, but it does not have line symmetry like that. This piece would end up here, and this piece would end up here. It does not work. So that's a no. And L is a no. All right, dilations. This is very easy. Okay? So we're going to put our points on. First off, what does dilation mean? Get bigger or smaller. Okay? We're going to make the shapes bigger or smaller. So, graph the image. 0, 0. Right there. 3, 3. 1, 2, 3. 1, 2, 3. 6, 3. 4, 5, 6. 3. 6, negative 3. And 3, negative 3. Okay? So that's A, B, C, D, E. Now, we're going to make it smaller, a third smaller. Technically, we're going to multiply everything by 0. I'm sorry, my bad. By 1/3. Or you can think about it as dividing by 3. It's the same thing. Multiplying by 1/3 and dividing by 3 is the same thing. First one's easy. 0 times anything is still going to be 0, 0. All right? B, 3 divided by 3 is 1, so 1 comma 1. C, 6 divided by 3 is 2, so 2 comma 1. D prime, 6 divided by 3 is 2. Negative 3 divided by 3 is 1. And then 3, negative 3 is going to be 1, negative 1. So let's put these on. 0, 0, A prime is going to stay there. B prime is going to be at 1, 1. C prime is going to be at 2, 1. And then 2, negative 1, and 1, negative 1. And what we just have is a smaller version of the same shape. So here's B prime, C prime, D prime, and E prime. All right? J, 1, 3. 1, 1, 2, 3. 3, 3. And 2, 1. Nice little triangle there. We're going to multiply everything by 2. So 1 times 2, 3 times 2. 3 times 2, both. 2 times 2, 1 times 2. Where do those go? 2, 6. That's J prime. 6, 6. That's K prime. And 4, 2. That's P prime. And there we have a bigger triangle, a prime, bigger triangle. And that's your review.